This is Elise. She's sad and lonely, and she's looking for her other pair.
This is Hans. He is sad and lonely too, and he is also looking for his pair. But little do they know that they're each other's pair. One day, they both wanted to take a walk. On that walk, they crossed each other's path. At that time, they realized they were each other's pair.
Welcome back to
Finding my pair! Today we'll be discussing about forming polynomial equations with quadratic series and complex conjugate theorem. State quadratic series and complex conjugate theorem. Struggling with this topic.
Quadratic surds. Quadratic surds are irrational numbers that are solutions to some quadratic equations with rational coefficients.
Complex conjugate root theorem. Complex conjugate root theorem states that all imaginary numbers come in pairs.
Imaginary numbers. Imaginary numbers are numbers that are expressed in terms of the square root of a negative number. The unit is I.
Polynomial equations. Polynomial equations are the expressions that contains monomial, binomial, trinomial, and also the higher order polynomials.
The procedure of forming a polynomial. Given the roots, you always want to find the depressed form of each root. Then you multiply them to each other and equate it to 0. If all the roots are rational, simplify the equation until you're given the final answer. If there are roots that are irrational, use the sum and product formula. Just a reminder that all irrational roots come in pairs. To get the sum of each irrational pair, add the two roots to each other. To get the product, you multiply the two roots to each other. Once you find the sum and product of each pair, use the S&P formula, which is x squared minus sx plus p. Do that for all irrational roots and then multiply them to each other. Keep on simplifying until you get the factored form of the polynomial. Form a polynomial equation given the roots -1, 1/2, and 3. The first step is to make sure all roots are equated to x. In this problem, x equals -1, x equals 1/2, and x equals 3. To make sure you get the depressed equation in the end, transpose all roots to the same set of x and equate it to 0. The final answer should be x plus 1 times 2x minus 1 times x minus 3 equals 0. Form the polynomial equation with rational coefficients in its lowest possible degree with the roots square root of 2 and I square root of 2. Just a reminder that all square roots and imaginary numbers come in pairs. The first step is to write all the roots equal to x. So x equals square root of 2, x equals negative square root of 2, x equals I square root of 2, and x equals negative I square root of 2. Since these roots are irrational, you need to use the S&P formula. Write each pair on one side and find the sum of each pair. So the sum of square root of 2 and negative square root of 2 is 0. And the sum of I square root of 2 and negative I square root of 2 is also 0. To get the product, multiply each root and their pair. Why is the product 2 and negative 2? Square root of 2 times negative square root of 2 is equal to negative square root of 4. Now negative square root of 4 is equal to negative 2. Now you multiply the next pair. I square root of 2 times negative I squared of 2 is equal to negative I squared square root of 4. Negative I squared is equal to negative 1 times negative 1. Simplifying that is just positive 1. Lastly, 1 times 2 is 2. Lastly, use the S&P formula to form the depressed equation. Once you do that, simplify. Now you get x raised to 4 plus 2x squared minus 2x squared minus 4 equals 0. Simplify even more and your final answer is x raised to 4 minus 4 equals 0. Form the polynomial equation with rational coefficients in its lowest possible degree with the roots 1 minus square root of 2 and 1 minus I squared of 2. Just a reminder that all square roots and imaginary numbers come in pairs. Next, you make sure all roots are equal to 0. For this one, it should be x equals 1 minus square root of 2, x equals 1 plus square root of 2, x equals 1 minus I square root of 2, and x equals 1 plus I square root of 2. Next is the sum and product formula. Draw a line and make sure each pair of roots are on the same side. Simply add the two roots to get the sum. For the first one, the sum is 2, and for the second one, the sum is also 2. To get the product of each pair, just simply multiply them together. For the first pair, the product is negative 1, and for the second pair, the product is 3. Why the products negative 1 and 3? You multiply the pair together, so in this case, it's 1 minus square root of 2 times 1 plus square root of 2. Then distribute. 1 times 1 is 1, 1 times square root of 2 is square root of 2, negative square root of 2 times 1 is negative square root of 2, minus square root of 4. Then that simplifies to 1 minus 2, which equals negative 1. Then multiply the next pair. 1 plus I squared root of 2 times 1 minus I squared root of 2. Then distribute. When simplified, you'll get 1 minus I squared root of 2 plus I squared root of 2 minus 1 squared square root of 4. Simplify even more and you'll get 1 minus I squared times 2. I squared is equal to negative 1. So when you multiply negative times negative 1, you get 1. So 1 times 2 is 2 and 1 plus 2 is 3. Now you use x squared minus sx plus p for both pairs. When you substitute s and p for both pairs, you end up with x squared minus 2x minus 1 times x squared minus 2x plus 3. Multiply them together and you get x raised to 4 minus 4x cubed plus 6x squared minus 4x minus 3 equals 0.
To recap our discussion today, the steps we learned are:
Given the roots, find the depressed equation of each root. Then multiply them to each other and equate them to 0. If all roots are rational, simplify the equation until the final answer. If roots are irrational, then use S and P formula.
take note that irrational roots always come in pairs. Add the two roots to each other, then multiply the two roots to each other. Given the sum and product, use the formula x squared minus sx plus p. Do that for all irrational roots, then multiply them to each other, then simplify. And I hope you learned something today. Catch us tomorrow for another episode.
If you learned something new, like and subscribe.